Figure 8.1 Time1.java and Figure 8.2 Time1 Test.java. This example begins our time class case study, which we'll use several times throughout this lesson to introduce additional class building concepts that will help you build more robust classes and to help you build what we might refer to as valuable classes, or to craft valuable classes that could potentially be reused in your own programs or even other people's programs. Towards the end of this lesson, we're even going to show you how to build your own packages so that you can reuse your classes or give them away to other folks or sell them to other folks for reuse in their applications. Now, our Time1 class is the first version of class time that we're going to take a look at, and the Time1 class has three private instance variables: hour, minute, and second, and they represent the hour, minute, and second of the day in 24-hour clock format. So the hour value will always be from 0 to 23, and the minute and second values will always be from 0 to 59. Also, because we don't provide a constructor in this class, each of these variables is going to get its default value at the time that we create a new Time1 object. The default constructor provided by the compiler will ensure that that happens, and each of these will get the initial value of 0, which basically means that the initial time will be midnight in our examples. Now, at line 12, we have a setTime method that we're going to be able to use to set the time to a new value. At line 20, we have a toUniversalString method that's going to return a string version of the time in 24-hour clock format. And at line 26, we have a toString method that's going to be used to return a string format in 12-hour clock format. Let's go back to setTime and take a look at its details. The method receives three parameters to represent the parts of the time. It doesn't return anything, and it's public so that anybody using class Time1 can in fact set the time on a Time1 object. We're going to set the values for each of our three instance variables, and for those of you who are coming from a C or C++ background, you'll recognize the old question mark colon operator, which is basically a shorthand representation of a little if-else statement. The condition that has to be evaluated first in this case is checking to see if the hour value h is greater than or equal to 0, and to see if the hour value h is less than 24. If so, it's in range, and we will use the value between the question mark and the colon to represent the true result, and that value will be assigned to hour. If, on the other hand, the condition is false, 0 will be assigned to the hour to basically keep the value in a state that's consistent with the use of a time object. Now, granted, we are setting it to 0 rather than indicating that the value was invalid. This is a case where you might consider using exception handling, which is a topic that we discuss in detail in the second course of this two-course video sequence. We also set the minute and second using conditional operators, and in both cases we're checking the value to see if it's in the range of greater than or equal to 0 and less than 60, excuse me. And if it is, we take that value and assign it to minute or second respectively. Otherwise, we will set those to 0 as well to maintain our objects in a consistent state. And we'll demonstrate that to you in our test program in a moment. Our toUniversalString method takes no parameters because the data it's going to be working on are the variables hour, minute, and second, our instance variables. And we're going to use a new method that we haven't introduced before, the string classes format method. Now, you know that string is a class because by convention all class names in Java start with a capital first letter. And you also know that the only time you've ever seen a class name followed by a dot, that the method or variable name on the right side of that dot was a static member of the class on the left. So format is a static member of class string, and of course if you look up format in the online documentation you'll see that as well. And it works exactly the same way as system.out.printf does. The only difference is that instead of outputting the string, this method returns a string. So it uses a format control string to determine the formatting. In this case, we have three format specifiers: %02d, then a colon, %02D, then a colon, and another %02D. The 0 indicates that if the number doesn't fill all of the character positions in our 2-character field width, then the number will be preceded by a leading 0. So if the hour, for example, were 7, then the hour string representation would be 07 based on the highlighted specifier that you see here. Once we've formatted the whole string, this method returns a reference to the new string object that it creates, and we return that string back to the caller. Now, we've talked about the toString method once before as being special to all classes in Java. Remember that no matter what, when you build a class in Java, you are never starting from scratch. You always have at least the methods from class object, because in some way every class you ever create is related to class object in Java. And we're going to talk about inheritance concepts in detail in the second video course as well in this sequence. Now, the toString method must be declared as shown on line 26 if you want to be able to take advantage of some of Java's automatic capabilities or implicit capabilities for invoking this method. For example, if you simply want to output an object and you hand that object to the system.out.println method, it will that method, will first call toString on the object to obtain the object's string representation, and then it will output that string representation automatically. Similarly, if you add an object to a string, that's going to result in a string concatenation where the object will first be converted to a string by invoking this toString method implicitly, and then the string representation will be concatenated. So this is actually a pretty powerful concept. Every single value, every single object in all of Java has a string representation. Now in this case, we're going to return the string that comes back from the string.format static method call, and we have another format control string here. The hour format is simply going to be to output the hour in the %d placeholder, which means the hour value will simply be output as whatever its value is, a single or double digit, followed by a colon. Then the minute and the second values are each going to be output with %02D, indicating a 2-character field with leading zeros. And at the end, we're going to output an AM or PM string, so we have the %S specifier for strings. The hour value is output based on the value of this conditional expression. If the hour is either equal to 0 or the hour is equal to 12, then 12 will be the value we display. Otherwise, the value of this expression, hour %12, will be displayed. And normally this would result in a value from 0 through 11, but we've already dealt with the 0 case, so this is going to result in this part of the example as a value between 1 and 11. And in total, this expression will output a number from 1 to 12 to represent the hour in 12-hour clock format. We'll output the minute and the second as part of the formatted string using these two %02D specifiers, and then to figure out whether we need an AM or PM at the end, we check to see if the hour is less than 12. If it is, we use AM as the result, otherwise we use PM as the result. Now let's go ahead and take a look at how we use class Time1 test to test out class Time1. At line 9 in its main method, we create one object of class Time1 and we assign it to the variable time. Now remember, we always are going to be invoking a constructor for every new object we create. So this is calling the Time1 class's constructor that takes no parameters. And we did not define that constructor, so the compiler provided one for us. The only constructor that the compiler can provide for us in Java is one that takes no parameters, the so-called default constructor. So the new object is assigned to the time variable, and then we use the time variable to manipulate the object's data. And we do that starting with this block of code here at lines 12 through 16, where we're going to output the initial universal and standard time strings. And we do that by invoking the time object's toUniversalString method and then invoking the time object's toString method. And notice the syntax of the method calls. Once again, we have a variable name that refers to an object, and we're telling that object to do something. In this case, we're quote-unquote sending it the toUniversalString message, saying we want the universal string format of that time object. And in this case, we're sending it the so-called toString message, which is a method call indicating that we want the 12-hour string format. Now, if I stop there and go ahead and run this project, we can see what the initial output is from this block of the code, these two lines of output, where you can see that the 24-hour clock format was all zeros, and that represents 12 o'clock a.m. or midnight in the example. Now we continue in the example with the next block of code, where we first test out the setTime method to make sure that we really can set a new time. So we tell the time object to set its time to 13 for the hour, 27 for the minute, and 6 for the seconds, and then we use some output statements to prove that we were able to set the time. And again, notice we're invoking the time object's toUniversalString and the time object's toString methods. And here's the output that's produced. And you can see 13:27:06 for the 24-hour clock format and 1:27:06 p.m. for the 12-hour clock format. Now finally, we wanted to test out setTime once again, but this time using invalid values to show you that we are indeed validating the data. So we passed 3 values that are out of range for the hour, minute, and second, and that should result in us getting the time set back to all zeros. And to prove it, we once again output the string representations of our time object, and you can see now at the very end of the output here, the universal time is all zeros and the standard time is back to midnight. Now, one other thing I want to point out to you with respect to the toString method calls that we're doing is that we really did not need to explicitly call toString. Here at line 15, now that I've deleted the .toString, what I'm saying is I'd like to output the object called time using the println method. Now the println method does not know about Time1 objects, which is the declared type of this variable. It knows about the generic concept of an object, and it knows about all of the primitive types as well. So when I go and say to output some object that it doesn't know about, the only thing that println can do is get the string representation of that object and then output it. So this actually results in an implicit call to the time object's toString method as if I had written it explicitly, and outputs the string representation. So anytime you're outputting an object in string representation, and in the command line that's the way objects get displayed, you're going to get a free call to the toString method. Also, again, if you add an object of class time to a string, that too would result in the time object's toString method being called.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.